Okay, let's take a look at the handouts for Chapter 5 using our GeoGebra applications. So this first binomial distribution talks about a set of orange trees. Each orange tree has a 65% chance of surviving a frost, and there's an orchard with 6 trees. So let's talk about the 6 trees. So n equals 6. The probability of surviving is 0.65, so let's enter that. And notice that that gives us our probability distribution. So we can copy and paste those values in to our answer. And in a little bit we're going to look at the expected values, but let's start by asking the questions about this set of 6 trees. What's the probability that exactly 4 orange trees survive? So we're talking about between 4 and 4. So we can look up here and see 0.328. So 0.328, so about 33%. At least half the orchard survives. So we're going to change this to at least. So x can be no smaller than half. So we're taking that to mean 3. So it looks like 88.26%. So let's see that. So about 88%. Now it asks how many trees in the orchard do we expect to survive? So let's go back up to that table and complete it. To do that, let's copy this data out of the binomial distribution, and let's go to a discrete probability distribution for the statistics, and let's paste that information in. And we do so, we can see that the mean is 3.9001. So that's what you get when you add up all of the x times p of x's. So here's our x times p of x row, and you can see that that's been recopied as a column, and then there's our sum. So that answers the question, how many trees do we expect to survive? Now, I do want to point out that we already have this information in the bottom right-hand corner of our probability distribution. Mu is 3.9. So let's take a look at some expected values. Let's look at a game of chance. This involves a 6-sided dice. It costs $1 to play, so we're going to have to subtract $1 from any winnings. If the dice lands showing a 3 or a 4, then $2 is won. Let's see what happens when... So when $2 is won and it cost us $1 to play, that means that we're ahead $1. So this 1 here means that we're up $1. We have $1 more than we did before. Now that happens when we see a 3 or a 4 on a 6-sided dice. So 2 cases out of 6. That's 1/3 or 2/6. So we multiply those together, and of course 1 times anything is itself. It says if the dice lands on 5, then $5 is won. Of course that means that we are $4 ahead. That only happens 1/6 of the time. And of course 4 times 1/6 is 4/6. Keeping the 6th just so the arithmetic's a little bit easier. And then there's several other times. So the remainder of the time, we've simply lost $1, and that's half the time, or 3/6. And when we multiply across, of course, the only thing that happens is that that gives us negative 3/6. We then add these up, and it looks like we're going to get about 3/6 or 50 cents. So is this game fair? Nope. It looks like you're ahead 50 cents on average each time you play it. Now let's look at this in our GeoGebra apps. So let's enter these values. So we're $1 ahead 2/6 of the time. We are $4 ahead 1/6 of the time. And we're $1 behind 1/2 of the time. And it looks like the expected value is in fact 0.5. Okay, let's look at the last question. A certain firm has 3 salary echelons. There are 15 employees. 6 earn $32,000 per year. So let's look at the first value there, $32,000. And the probability of that, well, there are 6 employees out of 15, 6/15. The next one, 5 earn 34,000, so the 34,000 and 5/15 earn that, and then 4 earn 36,000, so 4/15. Of course, we're going to do the same thing, multiply across and then add down. And we can do this in our application as well. So 32,000, and the probability of earning that is 6/15. 34,000, and the probability of earning that is 5/15. And 36,000, and the probability is 4/15. And we can see that the expected salary, the average in that case, the weighted salary or the expected value, is $33,733.33.